Assalamu alaikum and hello viewers. In my previous video I showed you how the quantities like mass, mole and particles are linked, how the mole act as a link between the mass and particles. In this video I'm going to solve some numerical problems related to these quantities. So let's just move on. Here is our first numerical problem. This is from FSC part 1. Aspartame is an artificial sweetener. It has a molecular formula of C14H18 and H1O5. We are going to solve what will be the mass of 1 mole of aspartame and how many moles of aspartame are there in 52 grams of it, and mass, what will be the mass of 10.122 moles of aspartame, and how many hydrogen atoms are there if we have 2.43 grams of aspartame. So let's just solve this first problem. Alright, we need to determine the mass of 1 mole of aspartame, and we know that to determine the mass, to calculate the mass, we need to use the formula. Mass of a substance is equal to number of moles of the substance, that is N. We know that moles are represented by N, and the molar mass of the substance. This is the formula we are going to use to solve this first numerical problem. This is very easy. For this we need molar mass of aspartame. We can calculate molar mass of the aspartame using the individual atomic masses. Let's see. Here the molar mass of aspartame would be 294 gram per mole. I have calculated this for you already. Alright, we can determine the mass of aspartame. Number of moles, we are already given the number of moles here, the 1 mole of aspartame, and the molar mass of aspartame is 294. So the mass of aspartame in 1 mole should be 294 grams. So this is our first numerical problem solved over here. Now let's just move on to the second one, that is how many moles would be there in 52 grams of aspartame. Right, let's just move on to the second one. We need to calculate the number of moles in 52 grams of aspartame. We need to remember that the link between mass, moles and molar mass. This is the link we studied earlier in my previous lecture, where I told you if we need to calculate the mass and if we need to calculate the number of moles and we are given the mass of the substance, we can use this formula. Mass of the substance equal to moles and molar mass. If we need to determine the moles of the substance, we can use the formula mass divided by molar mass. So what we are going to which formula we are going to use the formula, that is the mole equal to mass of the substance divided by the molar mass of the substance. And the mass of the substance we are given over here is 52 grams, and we know we have already determined the molar mass of aspartame, it is 294 grams per mole. And solving this, let's just solve it. 52 divided by 294 is equal to 0.1768. So the number of moles in 52 grams is 0.1768, can be rounded off to 7. So is our second numerical answer. number of moles in 52 grams. Alright, let's just move on to the third numerical problem, that is the mass of 10.122 moles of aspartame. Okay, alright, now we are going to calculate the mass of this number of moles of aspartame. We already know that when we are given the number of moles of a substance, we can calculate its mass using this formula. Mass is equal to mole into molar mass. So let's just put this formula. Mass is equal to mole into molar mass of the substance, and mass is represented by m, and we have 10.122 moles, and the molar mass of the aspartame, we already know that is 294 gram per mole. So just multiplying this value, 10.122 multiplied by 294 comes out to be 297.868. 297 point 297.575.6 This is our third numerical problem solved here. Alright, what we are given here, the mass of aspartame, that is 2.43, and we need to determine the number of hydrogen atoms in these grams of hydrogen aspartame. This is a little tricky one. What we are going to do, we are given the mass of aspartame, that is 2.43 grams. What we are going to do, we are going to determine mole from this mass using the formula, that is mole is equal to mass over molar mass. Then what? Then we are going to calculate the particles, and here the particles are molecules of aspartame. So from these particles we are going to determine number of atoms of hydrogen. The number of molecules of aspartame are going to be calculated from the formula particles equal to moles into Avogadro's number. The last one, that is the number of atoms of hydrogen, are going to be calculated by unitary method, and we will be discussing in later having calculated the number of particles. Let's just see. The mass of aspartame is given here is 2.43 gram. So the number of moles will be, N will be equal to 2.43 divided by 294. 2.43 divided by 294 comes out to be 0.00826. Point 0.00826 mole, and you might have noticed that I have been writing mole as unit mol. So whenever you are writing mole as unit, so you do not need to write down the last e. Just have to write mol mole. These are the number of moles present 2.43 grams of aspartame. Now let's just calculate the particles, number of particles, that is the number of molecules of aspartame in this quantity of aspartame. So particle, that is number of molecules of aspartame, will be equal to number of moles, that is 0.0826 into Avogadro's number, and we know that Avogadro's number is 6.02 into 10 raised to power 23. Let's just calculate that as well. 0.00826 multiplied by 6.02 is equal to 0.0497. 0.0497. 0.0497. I haven't multiplied the value 10 raised to power 23. I'm just going to write it down here just like that. So let's just move this point. Currently, scientific notation, this point moves 2 times ahead. So the answer should be 4.97 21, because I have moved this for point 2 values ahead, so I have to reduce this value of 23 by 2. So these are the number of molecules present in 2.43 grams of aspartame. Now what we are going to do, we are going to calculate number of hydrogen atoms in these number of molecules. See, we have molecules of aspartame are equal to 4.97 into 10 raised to power 21. What we are going to do, we are going to determine number of hydrogen atoms from this value. Okay, let's just write down the formula of aspartame. We know that the formula of aspartame is C14 H18 N2 and O5. You can see that the number of hydrogen atoms in this one molecule, this is a one molecule of aspartame. One molecule of aspartame contains 18 atoms of hydrogen. So let's just make a relationship: molecules versus atoms of hydrogen. One molecule of aspartame contains 18 atoms, and if we have two molecules, it would contain 2 into 18 atoms, and if we have 4.97 into 10 raised to power 21 molecule, then we will be having 4.97 into 10 raised to power 21 into 18. The answer to that comes out to be 89.46 into 10 raised to power 21. Moving this value of this point over here, the answer would be 8.946 into 10 raised to power 22 atoms. So here is our last numerical problem. Number of atoms of hydrogen will be 8.946. So first problem solved here. Let's just move on to the second problem. For this, watch the next video, and please don't forget to subscribe our channel, and also do turn on the notification. See you.